In this video, I want to use GeoGebra to have a look at cubic equations. So cubic equations are anything which have an x cubed term in them. So we're going to create a few sliders and play with the different numbers in our equation to see what effect they have on the graph of our cubic. So we're going to create a slider over here somewhere, call it A, and have it going between -10 and 10 for me. So you're doing this along with me in GeoGebra. Then we're going to create a second one. Let's call it C and have it going within those same boundaries. So -10 and 10. Just grab that and move it over. All right, so now we're ready to graph our quadratic. So our quadratic is going to have y equals a times, so you're going shift 8 to get the little asterisks, and then x to the power of, so that's shift 6 to get your little up arrow, so the power of 3, and then plus c. So again, those a and c, they're numbers, and we're determining what they are based on those sliders. So we'll hit enter, and it'll graph our cubic. Let's just bring this down to 0 for me. So this here, with an equation y equals 1x cubed, or just x cubed, this is our most basic cubic equation or cubic graph. Let's have a look at what the coefficient of x cubed does. So we're going to change our a slider. Let's start off by making that bigger. So as we increase our coefficient, have a look at what happens to our graph. So you can see that as we increase it, it's getting steeper and skinnier. As we decrease it, it sort of flattens back out. And as we come closer and closer to 0, it gets wider. It flattens itself out. Now what just happened there, when I went past 0, is our whole graph flips over. So when our coefficient is negative, our graph switches over and it's in these two quadrants instead. Right, so when our coefficient is positive, looks like this, it's in the first quadrant and this third one down here. And when it's negative, it flips the whole thing around. But it still has that same relationship that big numbers make our graph skinny, whereas numbers closer to 0 make it a lot flatter. Okay, so that's what our coefficient does. Now I want to have a look at the constant term on the end. So this is very similar. The coefficient and the constant, they do a very similar thing to what they do when we're looking at parabolas. So the coefficient determines how steep our graph is and whether it's positive or negative. Our constant term on the end shifts our graph up and down. So if we have a constant term of 2, so +2 on the end, that means that our y-intercept is 2. So it's shifted that whole graph up. It's still the same shape, but it's shifted it up 2 units. If we brought that negative, again, our graph stays the same shape, but it shifts it down. So if we've got a -3.8 there, it's cutting that axis at -3.8. So our coefficient, just to clarify that, our coefficient changes how steep our graph is and whether it's positive or negative. And our constant term on the end shifts our graph up and down. It tells us its y-intercept.